Okay, returning to where we were, I made that change that I described in the description of the last video, and changed this to something called count, which I had previously had as a type def, just a simple type def, but now it's an explicit type, a uint, but an explicit uint. So therefore, no automatic conversions from Boolean or int or car or dword or anything, even uint. It has to be explicitly cast. I don't think I can use uint even. Let's see. Quickly check. It shouldn't allow that conversion. There's no automatic conversion from uint to count, even though count is a uint. The reason is because I'm using the explicit keyword for count for its constructor, and so whenever you want to use something that is a count, you have to say count. Even though nothing changed. It's still the same object, it's still the same type. You can see, well, I could change this to a reference so that there's no copying involved, but I use this sort of thing for built-in types. Complex objects don't usually require this kind of explicitness, but you could store a reference here, if I wanted to do that. But that's fine, I don't care about that, because I'm only going to ever use this for something like uint or in this case, long. I wanted to invent a type that was a number, but a number that is interpreted in base 10, so that when I stream it into a string, it won't print it out in hex. It'll print it out in base 10 digits. With commas as thousands separators. That's why I invented that particular cast. See, it printed it out in a base 10 format. It also works with negatives. See? Okay. Now, the other thing I didn't do in the last thing, and then I'll just do quickly, is print out the environment strings. And all I'm doing in order to do that is using the list iterate on this np list and printing out the resulting strings. So here is the argv0 and 1, and here's the environment variables. There's lots of space for environment variables. So that I fixed, and did I fix anything else? I didn't test something, which I need to test. Oh no, this is fine. Okay, so now on to the next thing. What if I want to include some switches? Now, typically, a program will have switches. Now, in this case, I won't add anything yet. If you look over at the constructors here, the 4 constructors, look at this one that's all fixed up now. There are 3 more to choose from. All of them start out with that $sign. Now I can just pass in a switches list of strings, or I can specify an ignore case specifier instead of taking the default. It doesn't tell you that the default is to ignore case, so if I want to be explicit about it, false. It also doesn't tell you that the default switch character is a slash, and I don't know how to really indicate that. This is in the header file, so you would see it in the header file. Or I can just specify everything, the switch character, the ignore case, and the switches. Okay? And in all of these cases, the command line will be validated. Okay, now is valid is a property of the structure that would become false if the command line were invalid, and if I specified some switches. Okay, so first let's just go with the default, and what we gotta do is invent some switches. I usually do it like this. TTC, so this is a pointer to T car, maybe PP, and make this an array, and I'll use my macro to set them. I usually do them just like this first, and then use a macro to do the underscore T part. I don't know, call it switch 1. Often things have different curves. Now I'm just gonna. These are just gonna be flag style switches. Print program name. Okay, just take a minute for the macro system to load up. How did that P get there? Okay. Now, so one of the constructors just takes the list. Okay. Now let's command line put some arguments. put in some of those switches. Now it turns out that, well, first I'll just say /recurse. Okay. Now, as you saw, the splitting of the arguments and switches happen in one step, so it doesn't matter where the switches go. We can put recurse here, and it's supposed to be case insensitive, so I'll use a capital, and we'll just see if that switch is set. So first things first. Print out the arguments, and now I have a thing called switches, but I won't use that first. First I'm going to say contain switch. Now I've got to use this name. Probably this has to be case sensitive. It has to come from the same list. How about this? So if it contains the switch recurse, I don't want to, I just want that. Otherwise, I want the word not followed by a space. Okay. The recurse switch was %s specified. Contains switch recurse. It was specified. Otherwise, it'll say not. And I have specified it. So I'm going to do it for all of my switches. Okay. Oops, now I gotta use the value. I just wanted to put an extra one and draw a line here or something. Okay, so the recurse switch was specified and none of the other ones were specified. And here's what I had. I don't have any recurse in my list here. It was case insensitive fine, and the way to determine if that switch was specified is to just call this contain switch. Let's look there. I just want to make sure we can easily see when things change. Okay, now the other one was switch 1. Right? Okay, now you can see that one was specified. What if I try something invalid? First off, is this invalid? What you're going to find is it's not invalid. That switch was specified, and the reason why, and I don't make this an option, it's always true, that you can use abbreviations. Now it turns out that all of these switches begin with a different letter. So the first letter, in fact, is good enough for any one of these switches. That's good enough for switch 1. Or for recurse /r. Okay. However, if I did /q or something, okay, there's a lot of asserting. We'll do it, I don't know if this is going to work. There's a way I can turn off those message boxes. It's supposed to work, it used to work, and then it stopped working. And this is 0. Oh, it worked. Okay. And it tells me. Okay, so I got an error invalid switch message. But the program continued to run as it normally did. I didn't get anything extra on here. But there's a way for me to determine that. And that is to ask if this is a valid command line. So I could do this. Okay. So it's up to you if you want to continue running the program. It's shown that there's an invalid switch. Maybe it should be enclosed and given its name. If it were a longer name, it would show the whole thing. Switch class. Actually, I do want that in place. You see how quick it is to do things when you have all the tools available? Okay. So now that's one thing. It's also true that when something is invalid, typically you want to print out some help. And suppose I made a function called help. Okay, now I'll hit pause and I'll quickly write it out. Okay, I've made a little help thing which describes command line and the switches. And, well, first let me show you. If the command line is not valid, I run the help thing and then return. Okay? So that's this case. Now, this wouldn't normally get printed out, but this certainly would. So they would see that an error, an invalid switch called quest was passed in, and now I'm printing out how to use the program. And you should always follow this, maybe not this format exactly. In fact, I think I would like to have an extra line here. First, usage. Now, this could be on the same line or a separate line, depending on space. Brackets means optional. Here I've said also an optional slash switch 1, and then optionally another switch, and dot dot dot, and followed by some arguments. Then each switch should be described to tell the person what each switch does. And you should always include at least one example usage of the program. Always, okay? And explain what the behavior of that example is. And that's how help should be done. Now, there's this is valid, but I've also combined is valid together with that help flag. So instead of saying is valid, you can say help requested, okay? Now that will have the same effect in this case. Whoops, except it would be the opposite. Whoops. Okay. Help requested is valid and help requested are the same. And another way, as I already told you, to get help is to do /question mark or minus question mark. This will also have that effect. And this will also have that effect. Okay. Now the reason for that, and I don't know why other people don't do this. Our program's called utest, right? Now why is all that printing out? Oh, okay, it just ran. There were no errors. Okay. Why did I print a utest here? Oh, argv0. Okay, that's just the program running. That should be a full path. That's weird. Usually the argv of 0 is the full path, but here it just says utest. Okay, learn something new every day. A relative path, the first argument could be a relative path. No, I don't want to see that box anymore, so put this back. Okay. and no, none of the switches were specified. Now, just doing what we were doing before. Now, the reason why the question mark thing is important, suppose I have some arguments. Okay, great big list of arguments, and now I've forgotten, I've forgotten about one of the switches. What I can do, right, instead of getting rid of this entire command line, which has already got a bunch of stuff typed in, I just, put a question mark here, get the help out, review the thing, and oh yeah, print product is what I wanted, so then I can do that. Okay. Now that allows you to very quickly find out help about the program without losing your current command line. Although you can usually retrieve it, my method is I usually go to the beginning and make this invalid, right? Then go and check the help, and then find this in the command history and get rid of the invalid part and fix it up. But if people were thought about it for a minute, they should realize that it should always be an option to look at the help without doing any processing. I could continue processing, but I always put as the first line, if help requested, print out the help and return. Don't do any more processing. And that's just an option. I don't have to, but why not? Okay. Now, one more thing before I go and show you how all this works. I'm going to add another switch. Okay, so now recurse and remind /r is not going to be good enough in this case. So what I'm getting here is ambiguous switch R could be recurse or could be reminder. Okay, and then I'm printing out the help. See? That also turns on the help requested flag. So first it's printed out information about the error the user gets to see. Then the help is printed out and everything and nothing gets processed. RE is also a conflict, but REC is okay. That's recurse. I'm not printing out the other one. I think I can do this in a loop. Well, it might not line up as well anymore. using a bracket where now these, by the way, are just flag type switches. I think they're also, those aren't the only kinds of switches in the world. So, %s. Let's see. 3, 4, 5, 6, 7, let's say 15. That might do it. There we go. Although I don't want the quotation here, right? And that's, again, so it's good to have these utility strings. There's quote and quoted. Quote modifies the string, and quote doesn't matter in this case. Quoted doesn't modify the string. Okay. I have quote and quoted and capitalize and capitalize. There are a couple ones that I've added to the string class. Very easy function. No, it's not capitalized. Oh, I added it in the other project probably. Yeah, I did, yeah. So that's a good one to have. Now I have to keep these things in sync somehow. I'm going to transfer all these fixes I just made over here. I am paused. Okay, all done. It's a very easy function to write, to capitalize. I just take away the first letter, and 2 upper that, and 2 lower the rest. And run my program. See, they've been capitalized. Capitalized. Yeah, I can capitalize. Now the question is, what happens first? It's going to be capitalized first, then quoted, and then padded. That's the order I want. See? But you see, as you add these, it's easy to add these utilities, and then add more and more things once you've got the tools. Once the tools are available, then making more tools, just like adding to the box was one of the first lessons was add it to the box, don't rewrite code. Okay, now I've done all that in one line. I could have separated it on 2 lines. I could make a new function which quotes and capitalizes and pads, all in one step, whatever. Very easy. Okay, so now that shows you what a conflict is. Now, how does that work? How does it work in agenda? Okay, first, this ends up in the template constructor, which is our switches thing. There are the switches, and the count automatically computed. And I want it validated, and the switch card / and here's argc. Okay. Setting up some variables because we're constructing something. We're initially assuming it's not a valid thing. Now I'm going to go through to up to here and do I have no, I got help. Okay, so no help was requested, and that's all that this first part does. Is it returns immediately if there's a help request. These pointers have been set up, and now I'm going to go through. I started adding this, but I don't need it, so let me just get rid of that. I didn't see the return. As I showed you before, arguments will go to arguments and switches will go to switches. So actually we run all the way up to here. Our list of arguments is first the program name, argument 1, and another, and that's it. What about the switches? Now, a switch is a struct, and here's the data in that struct. It has a name, okay? It may or may not have a value associated with it, and then there's something called a delimiter. Now, for a Boolean switch, it's either it's on or off, right? Either it exists in the list or not. And these switches that I've defined are Boolean style switches. I'm not specifying anything more than a name. These are just names. Okay? Alright. So, where are we? So I've got a list of Boolean switches. Do the environment variables. And now we're going to validate. Okay, first thing is whether or not we're ignoring case. True in this case, so I've defined a headwise comparison for switches, which is a member function of TsString, to be either head insensitive or case sensitive. In this case, it'll be this one. And now this is a little bit of a walk on the wild side, but not in this case, because there are no parameters to my switching. Okay. First, I already have a bunch of these things in the list. Okay, whether or not they're valid is something to be determined. Now I have I invent another switch, currently undefined, and then I need a third switch to called the possible switch to make some comparisons. Alright, now first I have this array which has the array passed in, which has all of the switches. Or is that passed in here? It's passed in here, okay, and count. Those are the full switch names. Whether or not a switch has a parameter depends on whether or not there is an open brace, a right pointing angle bracket somewhere in the switch name. Okay, none of them have that, so they're all non-parameter type switches. Okay, now I don't even need this. This should have been done already. This is like legacy. I can get rid of this. Has parameters? No. Now I just check if the name is, if the full name of the switch is head equal to possible switch, which is S, which is what we've been passed in, name. Head equals is a thing where a long string is compared against a small string and is true if the long string starts out with a small string. So like for instance, and my name is Alan Carr, so Alan Carr dot head equals Alan is true. Okay, but not the other way around. A long string can be head equals to a small string, but not the other way around. So they are head equals. Okay, so a possible switch, their name now has become switch 1. Now the matched switch is empty. And I'm setting matched switch to what we have. This is like a temp, I guess, and I've set it. I've found a match for S, okay, and I'm remembering I, which is 0. Next, R switch. Our switch is the switch that we're currently working on. So now we're back to possible switch again, what we started out with. Now we're checking for parameters again, because we don't need. What are we on for? Recurse. So now we're on recurse. So if recurse head equals S, we do something. It doesn't, so we continue, and so on. And unfortunately, the one that we're working on is S, which is not going to have any constant. I'm glad we're not going to get any conflict. Eventually, it may occur that Oh, we have matched switch, so okay. If not empty. Let's see, I have to step through it to see. Nothing else is matching. If eventually if this continue doesn't happen, right, then possible switch name will become another name besides the last one, and it's going to continue through here. And this is already going to have a name, right? So then we'll print out that message with the match, the first match we found, and the current possible switch it could be, and that's the conflict. Print out the conflict, wait for someone to press a key, and then return. Okay? Complicated little piece of little piece of coding that had to be done. Don't need that anymore. Okay, so let's invent a conflict. Now what do we have? Recurse and reminder. Okay, and they don't have to be the same way. How would I do that? And put /r here. Okay. And go to our validate function. All the switches are gathered. Now, the first switch being taken out is R. Okay, and now this is like our temp. Now we're walking through up to 4, because 4 is the length of the switch, the total number of possible switches there are in the world. Okay, now the possible switch is what we currently have. Extract a full name. Does the name match with R? Does switch 1 match with R? No. Continue. No. Why? There's a reason why I have to do this again. This hasn't changed, but it can. Okay, now the next one, recurse. Now this is going to become true. So recurse is head equals to R. So now we're going to replace what was a possible switch /R with a fully named switch, and now possible switch is recurse. Match switch is still empty. If it's not empty, do something. So now we're making it not empty. We found a match. I'm remembering where it was. Okay. Now, possible switch goes back to what we started with, R. Okay, that's why I have that here. Okay, now the next name we found is reminder. Okay, now does reminder, is that head equal to R? Yes. So that possible switch's name is reminder. Now match switch has been set to something already. So we found a match, and we found another possible match. So we enter in here, print out that message. It hasn't been printed yet. Ambiguous switch R could be one of these two. Wait for a key to be pressed, and return. I should have. Oh wait, not valid. Okay. Now, do we need help? Help requested or not valid? Is valid is false because we never completed the validation. So that's false. So not false is true. So therefore help has been requested. We print out the help and we're done. Okay? Now I know this all seems rather complicated. But really, that's 99% of it. The difficulty now comes in a case where switches have parameters. We've dealt with the problem of separating the switches. We can check with the switches, Boolean type switches, if they're true or false. We won't get any conflicts. We can use abbreviations. We can request help on the command line at any point. And everything's going great. Now the last step is to incorporate the possibility of switch arguments. That is, I might have a program. Here, for instance, I have one. Rand string has an optional parameter. So first, it has a default thing. Yeah, it's a very big long string, and it has a parameter length, and I can set that to like 2, and it'll give me a random string of length 2. See? Or I want 10. So this switch has an argument, and we want to be able to handle that. It also has a whole bunch of other options. I can change the character set. I can use the uppercase letters or lowercase letters. I can combine things. Some examples are given. So it has a /set, which has optional parameters, length, and so on. Okay. Now you would have think a lot of work would have gone into to doing something like this, but once we can solve the problem of incorporating parameters for switches, then we're done. And the way I chose to do it is to use an angle bracket, and it works this way. Let's go and change the switch to length. By the way, you'll notice that this was lem, but I used the abbreviation L because it's no conflict. Okay, length. Now, in order to indicate that it takes parameters, I use a right arrow or a right pointing arrow. Now there's the problem of what separates the switch from the parameter, like what character will separate them. An equal sign, or a colon, or a dot, or a slash, or whatever. I typically choose equals. Okay. So now I have length. Takes parameters, and the parameter is separated from the switch by an equal sign. Now first I'll just show you it working. Len equals 55. Now first, if I define it correctly, it'll fill in this value for me. So we'll print the name. Another possible thing, value, and the other thing is the switch delimiter. Things this equal sign here. Now if I've done this properly, then, and I've used the equal sign, so it should work. This should become true. However, maybe it doesn't come out true. Oh. It doesn't come out true maybe if I don't provide. Maybe if I don't provide, if it's a variable thing, like, oh, I know. I think that I have to do that. No, that's why it's not working. It's not working because that's what I'm putting in here. The switch itself is called length, not length bracket equal. So this should work. See? True. It came out true. And here's the data returned for that switch. The name of the switch is length. The value provided was string 55, and the delimiter character is equals. I don't need to provide that here. It already knows. Thus, I can fix my printout here with that. StirToken is a tokenizer. Bracket mistake again. Just a regular tokenizer. It returns everything up to the first of one of these tokens, and never returns a token, and never returns a blank string if there's something there. So if it was a string separated by spaces, and I use spaces, it would break it up into tokens. So the printout length was specified, and reminder was specified. That's not visible enough. You see how these things just pile together. Can you imagine, without all these little stupid little things that you add as you go along, how difficult it would be to get this in the format that I wanted it in. I wanted to take away the bracket equals thing. I wanted it capitalized, quoted, and padded, and all these things. And there it is, right? So equals looks funny. Or I have to use a colon. Okay, now here's the question. Suppose one recurse or reminder took arguments and one didn't. Okay, so let's suppose that reminder takes an argument, but recurse doesn't. Okay. Now that's not ambiguous, because if it finds a thing that is taking an argument, right, and matches, so a match with reminder plus argument, then it must be the reminder one. It can't be recurse. It possibly be no, because a switch on its own goes from beginning to end. Like this would be the switch with letters R equals 2, but there is no such switch. Or it could be reminder with value 2, or it could be recurse. Well, it's certainly not recurse because there would have to be an E here. So there's no ambiguity here, and that should be okay, and I shouldn't get a problem. Okay, now reminder was specified. Recurse was not specified. There's no error, even though I just used /r. So now it took me a long time to work out that problem. In the verifying logic. where it was. Somewhere up here. Okay, now I'm handling delimiters here. So now we did the no parameters case, which was easy. If there are parameters, then I have to find a switch whose full name is something that is a head equals match and contains a bracket. Now I don't know about this one equals. Oh, that would be like if you said L equals but provided nothing on the right. Now the expected delimiter comes out of this string list provided. And I check and let's see if I find that delimiter. If I don't find the delimiter, there's a mismatch. So it's not a delimiter. That's just part of the switch. Otherwise, it is a delimiter. So the possible switch name it will be the one containing the delimiter, and the other one's not going to match. There's not going to be a name match, because even though I found a delimiter, the other one's going to come into here. Okay. No. No, because I'm always working with one switch at a time. So I'm either working with a switch that contains a delimiter or not. This has delimiters, has parameters, comes from possible switch, which is always refreshed to the initial switch, no matter what happens. So there won't be two matches for the letter R if I provide parameters. There'll be the one match that comes through this, and otherwise /R equals doesn't match any of the literal strings passed in. Okay, now that was long, very long, but that's the end of it. There's no more to be said. The command line problem is now completely solved, and so it's very easy now to create programs that use command lines of arbitrary complexity with arbitrary switches. The switch conflicts are checked for. Switches can have parameters. The parameters can be delimited from the name of the switch by an arbitrary character. Colon instead of an equal sign might be more useful. And when there's an error, this is always going to happen, and you can always print out help. And so that part of your program creation is done, and now it's just a matter of making up a program. And in fact, I made one, and the next tutorial I'll show you the most recent program I made. First off, actually I can run it for you. It's called info, which is something I used to have, and lost, and I made again. And what I want to do is print out information about DLLs and executables and copyright and so on. For instance, I'd like to go to my Windows System 32 directory and find out what DLLs there are not provided by Microsoft. And this program will enable me to do that. I can run this particular example. That's why the example is good. But I think I want to use quiet mode. I'll do this. So you see, it's printing out the particular things I wanted to find out about those programs. The default is to print everything else. So this is a typical output. Product name, company name, version. That's a copyright thing. And that gets if I redirect this into a file, then these will display correctly. These are in code page 437. The copyright symbol corresponds to that symbol. So I know that if I redirect it to a text file, you get the right character in there. See, I know it's printing out the right character, it's just the wrong code page. I don't know how to make this print out properly. It's quite slow, isn't it? I'll pause again. It was taking so long, I changed it to System 32. See? There's that registered trademark, here's that copyright thing. It's okay when I redirect to a file. Okay, now these are all the EXEs that were found in, well, either DUtil. I don't think there was any DLLs in there. Oh yeah, a couple of them. Oh, utils, yeah, certainly. And then the rest are Windows System 32. It's quite a lot of them. Sometimes things don't have version information. I'd like to add a flag that prints out the file names for all EXEs that don't have version information. Actually, I can't see one on here. No version information for this function, append.exe. I don't even know what it does. Allows programs to open as if they were in the current directory. Oh, that's interesting. Oh, there you go. Find something new every day. Debug, yeah. DOSX. Edlin. Now that's interesting. Now there are a lot of the ones that don't have version information are the interesting ones. I wonder what reader does. Resetver. Share, what does that do? That's it. Okay. So anyway, like I said, long but complete. See ya.